Some machines, they're so big, so powerful, and so specialized that they seem almost unreal until you see them in action. Here's 15 of the most gigantic moving machines in the world. Starting with number 15, the NASA Crawler Transporter 2. The NASA's CT-2, as it's known, is one of two massive vehicles built in the 1960s to carry rockets from the Vehicle Assembly Building to the launch pad at the Kennedy Space Center in Florida. It was designed by the Marion Power Shovel Company. These crawlers remain among the largest self-propelled land vehicles ever made. The CT-2, after several upgrades, continues to serve in the Artemis program, moving the Space Launch System rocket and the Orion spacecraft for future lunar missions. This machine measures about 40 meters or 131 feet long, 35 meters or 114 feet wide, and a height adjustable between 6.1 and 7.9 meters. That's about 20 to 26 feet. That keeps payloads level during the transport. Fully loaded, it can weigh over 8,000 metric tons, so this massive scale is necessary because it has to safely carry the rockets and their launch platforms, which together can weigh several thousand tons. The crawler moves on 8 giant tracks, 2 at each corner. Now, each track consists of about 57 shoes, with each shoe weighing around 2,000 pounds, and it travels at a maximum speed of about 1 mile an hour, unloaded, and about 0.8 miles per hour when loaded. The short trip from the Vehicle Assembly Building to the launch complex, which is about 4.5 miles, can take around 8 hours. So it runs on 16 traction motors powered by massive diesel engines. It features a sophisticated leveling system to adjust the platform to keep the rocket vertical. Now, the precision is critical because any significant tilt could damage the rocket or its systems. Operating it, of course, requires a skilled crew. Drivers, engineers, and technicians, they monitor every system throughout the journey. That slow speed and steady pace is deliberate, ensuring that this multi-billion-dollar rocket arrives at the pad intact. Although the appearance is purely functional, more like moving an industrial platform than a vehicle, it's an icon of space exploration. The sight of the crawler carrying a rocket to the pad with Florida's sun rising in the background is one of the most amazing images from NASA's launch history. Number 14, the Overburden Conveyor Bridge F-60. Nicknamed the Horizontal Eiffel Tower, the Overburden Conveyor Bridge F-60 is one of the largest movable machines on the planet. Built in former East Germany in the early 1990s, it was designed to remove overburden, that's the soil and rock that covers a coal seam, in large open-pit lignite mines. Now, while it doesn't dig like a bucket wheel excavator, it is an essential companion to those machines, carrying away the debris that they remove. The F-60 is extraordinary in length. It measures over 1,600 feet from end to end. That's about 500 meters, making it longer than many skyscrapers are tall if they're laid on their side. And its total mass is around 13,500 metric tons. Because of the sheer length and size, people often compare it to a bridge. And in essence, that's kind of what it looks like, a moving steel-framed conveyor system mounted on these massive steel tracks. Now, this conveyor bridge works by spanning across the open pit. Excavated overburden is fed onto the conveyor belts from one side and deposited at the other, allowing continuous removal of material while mining progresses. Now, this multiple belts can transport thousands of cubic meters of material per hour, reducing the need for fleets of dump trucks. Movement is achieved through a set of crawler tracks at each end, enabling the F-60 to slowly shift position as the mining phase advances. The machine's travel speed is pretty slow. It's often less than a kilometer per hour, and it's balanced by the enormous capacity, though. Power is supplied electrically via external connections, and the control systems coordinate the conveyors and track drives to maintain its stability. The F-60 is a reminder that gigantic moving machine doesn't always mean height and bulk. It can mean sheer length and the ability to move huge amounts of material with minimal manpower. Its design remains unique in the mining industry, and its continued presence is an example of the scale of engineering required for large-scale extraction. Number 13, the Prelude LNG, the largest floating offshore facility. The Prelude LNG facility, operated by Shell, is the largest floating offshore structure ever built and one of the most massive moving machines in existence. It was constructed by Samsung Heavy Industries in South Korea and completed in 2017. Now, the Prelude is not a ship in the traditional sense. It's a floating production platform capable of extracting, processing, and storing liquefied natural gas at sea. It measures about 1,600 feet long. It's longer than 4 football fields, about 243 feet wide. The displacement is around 600,000 metric tons when fully loaded, and it makes it heavier than the largest aircraft carriers. Now, despite its size, the Prelude can be moved using ocean-going tugs, although it's designed to remain stationed over a gas field for extended periods. Its primary function is to process natural gas extracted from beneath the ocean floor, cool it to about -260 degrees Fahrenheit, turn it into a liquid, and store it in massive tanks within the hull. This eliminates the need for long pipelines to shore-based LNG plants. At full capacity, it can make about 3.6 million tons of LNG per year, along with 1.3 million tons of condensate and 0.4 million tons of liquefied petroleum gas. Now, it operates using a sophisticated mooring system. This is a massive turret that allows the structure to rotate with the wind and currents while remaining anchored to the seabed. The turret is nearly 328 feet tall with a diameter of about 100 feet, and it contains the flexible risers and lines that connect the Prelude to the subsea well. Power on board is generated by a combination of gas turbines and diesel generators, and it produces tens of megawatts to run compressors, refrigeration units, and other processing systems. The whole facility houses a crew of around 220 people during peak ops, with living quarters, control rooms, and safety systems designed for long-term deployment. Since entering service off the coast of Western Australia, it's faced some technical challenges and periods of shutdown from maintenance and modifications, but nevertheless it represents a pioneering step in offshore gas production, allowing resources to be tapped in locations too remote or deep for traditional platforms and pipelines. Its scale and complexity make it one of the most remarkable moving industrial machines ever built. Number 12. The Bagger 293, the world's largest land vehicle. The Bagger 293. It is one of the largest terrestrial moving machines ever built, and it holds the Guinness World Record for the heaviest land vehicle. Manufactured by the German company Takraf in 1995, it is a bucket wheel excavator designed primarily for lignite mining. It stands about 96 meters, 314 feet tall, and about 225 meters or 738 feet long, and it weighs about 14,000 metric tons. It operates in open-pit mines. It uses massive revolving bucket wheel to continuously scoop earth and minerals, moving thousands of tons of material each day. Now, the bucket wheel itself measures around 70 feet in diameter, that's 21 meters, and has 18 buckets, each of them capable of holding over 15 cubic meters, that's 20 cubic yards of material. This continuous operation allows the Bagger to move roughly 240,000 cubic meters of earth daily. That's 8.5 million cubic feet. Now, movement is slow, as expected from a machine of this size. It rides on 12 Caterpillar tracks, each the size of a small house, and it can travel at a maximum speed of about 0.3 miles per hour. And because of its size, relocating it even short distances requires careful planning and sometimes involves preparing special paths to prevent ground damage. It's powered by electricity supplied through external cables, and it consumes several megawatts during operation. It requires a large team of operators and maintenance staff, often working in shifts to keep it running nearly continuously. Despite its efficiency, though, in moving huge amounts of overburden, the Bagger 293 has become a subject of some environmental debate. Of course it has. The lignite mining is one of the most carbon-intensive forms of energy production, and these huge excavators symbolize the industrial impact on the land. In recent years, some of the mines where it operates have been at the center of protests advocating for a faster transition to renewable energy. Even so, the Bagger 293 is a marvel of engineering and an example of what can be achieved when machinery is scaled to extreme proportions. Number 11. The P&H L2350 Wheel Loader. The P&H L2350, originally developed by LeTourneau Technologies, now owned by Komatsu, holds the Guinness World Record as the largest wheel loader in the world. This machine is designed for loading haul trucks in large-scale mining operations where speed and efficiency in moving material is crucial. The L2350 is about 22 feet tall at the cab and has an operating weight of roughly 266 metric tons. Its bucket has a capacity of 40.5 cubic meters, 53 cubic yards, and it's capable of holding around 72 metric tons of material in a single scoop. This allows it to fill even the largest mining haul trucks in just a handful of passes. Now, the size of this thing requires enormous power. The loader's equipped with a 2,300 horsepower diesel engine, giving it enough force to push into dense ore piles and lift the massive load. The articulated frame allows for steering flexibility despite the bulk, and the machine rides on huge tires, each more than 13 feet in diameter. Now, this thing's combination of strength and speed help reduce the turnaround time for trucks in a mining cycle, directly impacting the productivity of the mine. Operators work from a high vantage point in an enclosed, climate-controlled cab with modern instrumentation, cameras, and monitoring systems. While it can move under its own power at speeds of about 12 miles an hour, the loader's primary role is short-distance maneuvering in the loading area. This massive size means it's assembled on site in mines rather than driven from a factory. Maintenance, of course, is intensive, involving frequent checks of hydraulic systems, engine performance, and tire condition. The L2350 is a rare sight outside of any major mining region, but within the industry, it's regarded as a symbol of scale, able to move an extraordinary amount of material in a very short time. Number 10. Big Brutus, the giant electric shovel. Big Brutus, what a name! It's a preserved example of one of the largest electric mining shovels ever constructed. Built in 1962 by Bucyrus Erie for the Pittsburgh and Midway Coal Mining Company, it was used in the coal strip mines of southeast Kansas until 1974. Now, although no longer operational, its size and the engineering in this thing make it an iconic representation of the mid-20th century large-scale mining industry. The machine is 49 meters or 160 feet tall and weighs about 5,500 metric tons. Its boom extends over 55 meters, that's 182 feet from the base, and the dipper bucket has a capacity of 69 cubic meters, 90 cubic yards. It's capable of scooping more than 150 tons of material in a single load. Big Brutus was powered entirely by electricity, supplied through a trailing cable connected to an external substation. This allowed it to run massive electric motors to power the hoist, swing, crowd, and propel functions. The primary job was to remove overburden, that's layers of soil and rock covering the coal seams, so that smaller machinery could extract the coal itself. Unlike smaller excavators, Big Brutus wasn't designed to travel long distances. The maximum speed was only about 0.1 miles per hour, and relocating it required careful planning. Despite that though, the reach and bucket size made it extremely efficient in its time. After more than a decade of service, Big Brutus was shut down when deeper mining became uneconomical in its region. Rather than being scrapped, it was preserved in place and eventually turned into a museum centerpiece. Today, visitors to the Big Brutus Museum in West Mineral, Kansas can walk around and even step inside parts of the machine to see the scale of this thing up close. It remains one of the largest remaining examples of a mining shovel, and a reminder that the industrial push for efficiency during the height of coal strip mining in the U.S. Even in retirement, Big Brutus is still an impressive sight. It towers over the Kansas plains as a monument to an era of massive moving machines. Number 9. The SSCV Sleipnir, the world's largest crane vessel. The SSCV Sleipnir is one of the largest crane vessels in the world and a colossal semi-submersible platform designed for heavy lift operations in the offshore oil, gas, and renewable energy industries. Built by Sembcorp Marine in Singapore for the Dutch company Harima Marine Contractors, Sleipnir entered service in 2019 and immediately set multiple lifting records thanks to its unmatched capacity. At over 220 meters in length and 102 meters in width, Sleipnir is an immense floating construction site capable of working in some of the harshest environments. The deck area covers more than 2 football fields and provides enough space to carry and assemble massive structures like topsides for offshore oil platforms, wind turbine components, and other heavy modules. The ship's defining feature is the pair of revolving tub-mounted cranes, each with a lifting capacity of 10,000 metric tons. Together, they can perform tandem lifts of 20,000 tons. That's more than the combined weight of 100 blue whales. These cranes are designed to operate with precision even in rough seas, and their enormous reach allows Sleipnir to lift heavy structures directly from transport barges. The crane's slewing systems are engineered for its stability, ensuring that during extreme lifts the vessel is steady. And the Sleipnir is also notable for being the first crane vessel of this size to operate on liquefied natural gas (LNG) as well as a conventional marine fuel. That dual fuel capacity reduces emissions significantly compared to traditional vessels, aligning with the growing demand for greener offshore operations. Its 8 dual fuel engines generate a total output of over 96 megawatts, supplying the power needed for propulsion, positioning, and the operation of those cranes. Sleipnir has a semi-submersible design. That means it can ballast down to lower its pontoons beneath the surface, reducing motion from the waves and providing a more stable platform. That's critical for placing massive structures with millimeter precision, especially when working with fragile assemblies like offshore and wind turbines. Number 8. The LeTourneau L1100 Wheel Dozer. The LeTourneau L1100, introduced in the mid-20th century by LeTourneau Technologies, it's designed to handle the toughest pushing and clearing jobs on mine sites, haul roads, and large projects. Measures about 13 meters or 43 feet long and weighs in at over 100 metric tons. The L1100 was powered by a massive diesel engine that generated more than 1,000 horsepower. This power was delivered to huge wheels equipped with industrial-grade tires over 10 feet in diameter. The enormous blade, which is 23 feet wide, could move huge amounts of earth, gravel, or overburden in a single pass. Now, unlike track dozers, the wheel configuration of the L1100 allowed it to travel much faster between work areas, often exceeding about 12 miles an hour. That mobility, combined with the blade capacity, made it especially useful for tasks like clearing overburden. Hydraulic controls give precise handling of the blade, enabling the operator to contour the terrain, spread material evenly, or even push massive loads directly into stockpiles. Now, while the L1100 is a specialist machine built in limited numbers, its impact in large-scale mining was significant. It reduced the time needed to move material and kept the mine operations running efficiently by ensuring roads and dumping areas were maintained in optimal conditions. And although newer and more advanced models have replaced it in most places, some L1100 units remain in service. For anyone who stood next to one, the scale is amazing. It's a dozer so large that its blade alone dwarfs any small vehicles. Moving on to number 7, the Marion 6360. The Marion 6360, it's universally known in the mining industry as the Captain, which is a way better name. It was the largest power shovel ever constructed, and even in decades after its retirement, it remains unmatched. Built in 1965 by the Marion Power Shovel Company for the Southwestern Illinois Coal Corporation. At that time, the economics of coal production favored machines that could remove as much overburden as possible in a single pass. The Captain was the ultimate expression of that philosophy. Standing at about 160 feet tall and weighing about 12,000 metric tons, the Captain was a towering presence. Its boom extended 215 feet from the base, and it carried a dipper bucket with a capacity of 180 cubic yards, or around 138 cubic meters. Fully loaded, this thing could hold more than 300 tons of material, allowing it to strip away massive sections of overburden. Now, the Captain was powered entirely by electricity, supplied through a heavy trailing cable that was connected to a dedicated power feed. Inside the structure were a series of massive electric motors that was each dedicated to a specific function. These motors delivered immense torque, and despite its enormous size, the Captain could be manipulated with fine control, allowing operators to dig efficiently without damaging the machinery. Daily inspections were necessary to monitor the condition of the cables, the gears, and the motors and the structural components because the stresses on the boom and bucket during operation were immense. During its working life, the Captain became an icon of American surface mining. Its size dramatically increased the efficiency of overburden removal, which reduced the time required to expose the coal seams. For the Southwestern Illinois Coal Corporation, it was a key asset that enabled them to remain competitive in an industry where production volumes directly influence your profitability. Number 6, the Caterpillar 797F. The 797F by Caterpillar is the flagship model in their ultra-class haul truck range, and it's one of the most recognizable pieces of equipment in mining operations. It was introduced in 2008 as the third generation of the 797 series. It was designed to carry the heaviest loads over the most challenging haul roads in open-pit mining. At first glance, the size is what commands your attention. It measures about 49 feet in length, 32 feet in width, and about 24 feet high. With the dump body lowered, it dwarfs even large construction equipment. It's got an empty operating weight of about 600 metric tons and a rated payload capacity of over 363 metric tons. This means it can haul more than 250 average passenger cars worth of material in a single trip. Power for this thing comes from a 20-cylinder, 4,000 horsepower Caterpillar diesel engine. It's a 4-stroke turbocharged after-cooled unit with a displacement of 106 liters. It delivers exceptional torque, allows it to maintain speeds on even steep haul roads with a full load. Despite its size, it can reach a top speed of 68 kilometers an hour. That's 42 miles an hour on level ground. That's impressive for a vehicle weighing over 500,000 kilograms. The suspension is hydropneumatic, meaning it uses nitrogen-filled suspension cylinders to absorb shocks while carrying the load, and braking is handled by oil-cooled multiple-disc brakes on all 4 corners. That's supplemented by a dynamic retarding system. This dynamic retarding allows the truck to safely control its descent on long downhill grades. The operator's cab is designed for both comfort and safety. It features a pressurized environment to keep out dust, climate control for extreme hot or cold weather, and excellent visibility. The controls are ergonomically arranged, and digital monitoring systems display vital information including the payload data, the engine health, and brake temperatures. Caterpillar does also offer optional autonomous operations, allowing the 797F to be run without a driver in mines equipped with the necessary guidance and safety infrastructure. Fuel capacity on this thing is 1,000 gallons and allows the truck to run long shifts without refueling. It's supported by their global service network, and many of the components are modular, means that they can be replaced or overhauled more easily than in earlier generations. This model is used around the world in major mining regions, including the iron ore mines of Western Australia, copper and gold operations in Chile and Peru, and the oil sands extraction in Canada. In many of these locations, the environmental conditions are extreme, and temperatures can exceed 104 Fahrenheit or 40 degrees Celsius in hot climates, or go well below freezing in cold ones. So safety is a major focus in the design. The size of this thing makes collisions with smaller vehicles potentially catastrophic, so features like proximity detection systems, high visibility lighting, and multiple egress points for the operator are included. Number 5. The Pelamis Wave Energy Converter. The Pelamis Wave Energy Converter. This was one of the most ambitious moving machines ever deployed in the marine renewable energy sector. It's a unique blend of mechanical engineering and oceanographic design that sought to transform the motion of the waves into usable electrical power on a commercial scale. Its movement was dictated entirely by the rise and fall of the sea, and while it didn't travel from point to point like a ship or a vehicle on land, the machine was in constant motion when operating, flexing, bending, and pivoting with every passing wave. This combination of scale, mobility, and purpose placed it among the most notable large-scale moving machines of the early 21st century. Now, it was designed in the late 1990s and early 2000s by Pelamis Wave Power. That's a Scottish company, originally known as Ocean Power Delivery. Offshore wind turbines were beginning to scale up in size. Tidal energy concepts were being tested, and wave energy was attracting some attention. The challenge for wave power, though, lay in creating a machine large enough to harvest the energy from the open sea while being durable enough to survive the unpredictable conditions in that environment. A single unit measured around 180 meters or roughly 590 feet in length, longer than many cruise ships, and consisted of 4 large cylindrical steel sections, each about 3.5 meters in diameter, connected by 3 hinge joints. These sections could flex in both the vertical and horizontal axis, which was essential for capturing the energy from the waves that can approach from slightly different angles. The joints between the sections contained hydraulic cylinders known as rams, which were the heart of the machine's generation system. As the ocean waves passed along the length of the Pelamis, the floating sections rose and fell relative to one another, and the hinge joints bent accordingly. The motion of each joint drove the hydraulic rams, which pumped high-pressure hydraulic fluid into accumulators. From there, it flowed through hydraulic motors that turned electrical generators. Now, this process was continuous. Every movement of the machine produced hydraulic flow, and every flow contributed to electricity generation. This design allowed itself to align it with prevailing wave direction automatically. This self-orienting capability minimized any stresses on the structure, and it ensured optimal energy capture. Now, each Pelamis unit was rated for a maximum output of around 750 kilowatts under ideal conditions. That's enough to supply electricity to several hundred average homes. Now, the long-term vision for the technology was to deploy multiple units in arrays, often referred to as wave farms. In such configurations, several Pelamis devices would be moored in parallel or staggered rows, their combined output feeding into a shared subsea power cable. A large array could potentially generate tens of megawatts, comparable to a small onshore wind farm. One of the deployments of the Pelamis technology was the Aquadora Wave Farm off the coast of northern Portugal in 2008. 3 Pelamis P750 units were installed, marking the first commercial-scale power project in the world, and this device was towed to the sites by tugboats moored in place and then connected to the shore grid via subsea cables. Mechanical issues in the hydraulic system and problems with the moorings required retrieval of the devices for repairs, and the project was eventually suspended due to the financial collapse of one of the main investors. Number 4. Siemens Wind Turbine Installation Vessel Innovation. The vessel Innovation, the Siemens wind turbine installation ship, operated by Deem Offshore, is one of the most advanced and largest self-propelled jackup vessels ever built. It represents a highly specialized class of moving machines designed to perform a singular task: transporting, lifting, and assembling the largest wind turbines in some of the most challenging environments. Innovation was launched in 2012, at a time when offshore wind was growing in scale and ambition. Earlier offshore wind farms had been built with smaller turbines, often transported and installed by modified cargo vessels or barges. As turbine sizes increased beyond the 5 and 6 megawatt class, a new generation of purpose-built installation vessels became needed. Innovation was one of the first to be designed from the keel up to handle turbines with capacities of up to 8 megawatts at the time of its commissioning. The vessel measures about 147 meters in length and 42 meters in width, with a deadweight tonnage exceeding 14,000 metric tons. This means Innovation can transport several tower sections, nacelles, and blades all at once, which significantly reduces the number of trips needed to complete a wind farm. One of its defining features is those 4 enormous jackup legs, each capable of extending more than 80 meters down to the seabed. When the vessel reaches the installation site, the legs are lowered until they make firm contact with the ocean floor. The crane on the Innovation is a heavy lift main crane with a capacity of up to 1,500 tons, mounted on a pedestal for maximum reach. The crane is capable of lifting entire nacelles, which house the generator, the gearbox, and the other key systems, straight from the deck and positioning them atop the tower more than 100 meters above sea level. Propulsion on the Innovation is provided by a dynamic positioning system, which uses thrusters that are controlled by GPS and onboard computers, and the vessel can achieve a transit speed of around 12 knots, which is modest compared to cargo ships, but it's fast enough for efficient relocation between ports. The vessel can accommodate over 100 personnel, including the crew, crane operators, engineers, and technicians, living quarters including cabins, mess facilities, a recreation area, and offices for project management teams are there too. But their operational history includes work on some of the largest wind farms in Europe, particularly in the North Sea and the Baltic Sea, where wind resources are strong and relatively consistent. It's installed turbines for projects like Gemini and other multi-hundred megawatt developments, and in each case, the vessel's capacity to carry multiple full turbine sets has allowed the developers to accelerate installation schedules and reduce the overall timeline. Number 3. The Takraf Tenova SR8000. The Takraf Tenova SR's 8000 is one of the largest bucket wheel excavators ever built. This was developed by the German mining company manufacturer Takraf. The SR8000 is designed for high-capacity overburden removal and raw material extraction. It's part of the same family of machines as the famous Bagger series, but was engineered with specific operational features. The SR8000 stands roughly 96 meters tall, goes for about 220 meters in length, and weighs over 13,000 metric tons, making it one of the heaviest self-propelled machines in the world. The heart of the excavator is the massive bucket wheel, which measures over 21 meters in diameter. As the wheel rotates, the buckets dig continuously into the mining face, scooping up earth or ore, depositing it onto an internal conveyor system. Like the other large bucket wheel excavators, this one's powered by electricity supplied through an external high-voltage cable. Multiple high-powered electric motors drive the bucket wheel, conveyor belts, and crawler tracks, while a sophisticated control system coordinates all movements to ensure efficient handling. Each crawler track is several meters wide, allowing the machine to move over relatively soft terrain. However, movement is deliberately slow, often less than 1 kilometer an hour, as stability and safety take precedence over speed. Relocating the machine from one section of a mine to another can take hours or even days, depending on the distance and the terrain. This machine has been deployed in some of the world's largest lignite and coal mines, particularly in Eastern Europe and Asia. Its size and capacity make it ideal for operations where large volumes of overburden have to be removed to expose the valuable deposits. And while environmental concerns have led to the decline of coal mining in some regions, machines like this one continue to be used where demand for large-scale mining persists. Even in an era focused increasingly on renewables, the SR8000 remains an example of what's possible when engineering is pushed to create machines capable of moving mountains, literally, in the pursuit of raw materials. Number 2. The Big Musky Dragline. Big Musky. It was the largest dragline excavator ever built, and one of the most massive mobile land machines in history. Constructed in 1969 by the Bucyrus Erie Company for the Central Ohio Coal Company, Big Musky was designed to remove overburden in a large open-pit coal mine. Big Musky was colossal in every sense. It stood about 68 meters, 222 feet tall, was 148 meters or 487 feet long, and it weighed about 13,500 metric tons. Its boom extended an incredible 94 meters, that's over 300 feet, and its bucket, the largest ever fitted to a dragline, had a capacity of 220 cubic yards. Each bucket weighed over 295 metric tons. Yeah, Big Musky was enabled to move more material in a single pass than most machines could manage in multiple cycles. Unlike bucket wheel excavators, which operate continuously, a dragline excavator like Big Musky works a bit differently. The bucket is suspended from the boom by cables and lowered into the mining face, dragged across the ground to fill it with material, then lifted and swung to deposit the load in a spoil area. This cyclical operation is highly efficient in large-scale mining, especially when the overburden has to be removed significant distances away from the excavation site. Operating Big Musky required a skilled team of workers, including operators, electricians, mechanics, and ground crew. The operator worked from a cab way above the ground, with controls for hoist, drag, and swing functions. The view from the cab was essential for precision work, especially when placing overburden in a designated area. During its 22 years of operation, Big Musky removed hundreds of millions of cubic meters of overburden, enabling the extraction of tens of millions of tons of coal. However, by the early 1990s, changes in environmental regulations and declining demand for coal in the region made its operation less economically viable. In 1991, Big Musky was retired, and after several years of inactivity, it was dismantled in 1999. The enormous bucket was preserved, though, as a monument, and it's now displayed at the Miners Memorial Park in McConnellsville, Ohio, where visitors can walk inside it to appreciate its scale. Big Musky, it's legendary in the mining industry and among heavy machinery enthusiasts. The scale of this thing was unparalleled, and today, while modern draglines still operate around the world, none match the sheer size and bucket capacity of Big Musky. Number 1. The P&H 4100 XPC Electric Rope Shovel. So that's a mouthful of a name, the P&H 4100 XPC Electric Rope Shovel. It is one of the largest and most powerful pieces of mining equipment. It's manufactured by P&H Mining Equipment, now part of Komatsu. This one is the culmination of decades of refining a machine type that's been a cornerstone of surface mining since the early 90s. While smaller in overall footprint than the largest bucket wheel excavators or draglines, it is built for the same kind of industry, industrial-scale material handling. It's an electric-powered front-loading shovel designed to load ultra-class haul trucks with payload capacities that exceed 360 metric tons. It's intended for high-production mining. The shovel itself weighs in excess of 1,600 metric tons and stands nearly 20 meters tall from the ground level to the top of the machinery housing. The dipper, or the bucket, on this thing is massive, with a capacity ranging from 73 to 120 cubic meters, depending on the configuration and the material density. In terms of weight, each full load can exceed 100 metric tons of rock or ore. It's powered entirely by electricity, supplied through a trailing cable connected to a dedicated substation. The hoist system lifts the dipper vertically, the crowd system pushes it into the bank, and the swing mechanism rotates the entire upper structure to position the load over the truck, and then the dump system releases the material with a rapid door mechanism at the base of the dipper. The mobility from this thing comes from large crawler tracks, which distribute the enormous weight evenly over the ground. While the shovel moves at only a fraction of a kilometer per hour, this is sufficient for repositioning within a mine site. The undercarriage is built from high-strength steel components with a massive track shoe and roller design engineered to withstand years of continuous service in these abrasive environments. Many units are now equipped with advanced monitoring systems, and these systems help the operators maintain a consistent performance while avoiding overloading the haul trucks. That's a key factor in extending truck life and maintaining safe operations.